Hi, boys and girls. We're going to read about the Earth's seasons. We did our projects, which were amazing, and we're going to look closer at exactly how rotation of the Earth and the axis of the Earth lead to the seasons. So the main idea is Earth's rotation and its revolution cause day and night as well as seasons. Okay, the vocabulary words that we should keep an eye on are autumnal equinox, axis, revolution, summer solstice, vernal equinox, and winter solstice. Earth's tilted axis. Although you can't feel it, Earth is moving at close to 1,600 kilometers per hour. That is because Earth is spinning or rotating around an imaginary line called an axis. Picture Earth's axis as a line that goes from the North Pole through the center of the Earth to the South Pole. In relation to the Earth's orbit around the Sun, the axis is not vertical or straight up and down. It is tilted at an angle of 23.5 degrees. It takes 23 hours and 56 minutes, one day, for Earth to make one full rotation on its axis. As Earth rotates, different parts face the Sun. It is daytime on the side of the Earth facing the Sun. It is nighttime on the side facing away from the Sun. As Earth spins on its axis, it also moves around the Sun. One full trip around the Sun is called a revolution. Earth takes 365.25 days, or 1 year, to complete one revolution. The path of Earth's revolution is called its orbit. The orbit is a kind of oval shape called an ellipse. Because of Earth's tilted axis, different parts of Earth tilt toward or away the Sun during its trip around the Sun. The tilt causes seasons. In the photograph on page D32, the Earth's northern half is tilted toward the Sun. In this position, it is summer in the northern hemisphere and winter in the southern hemisphere. In the photo below, 6 months have passed. Earth is at the opposite end of its orbit. Now Earth's southern half tilts towards the Sun, so the seasons are reversed. Why does a tilt towards the Sun bring warmer weather? There are two reasons. First, when a hemisphere tilts towards the Sun appears to rise higher in the sky. The higher the Sun's position, the more concentrated its rays are as they strike Earth. Second, daylight lasts longer. More hours of daylight means more heating time. Together, concentrated sunlight and longer days bring warm weather in summer. Likewise, the combination of less concentrated sunlight and shorter days brings cold weather in winter. Regions near the equator do not have noticeable seasons. They receive about the same amounts of sunlight all year long. So we see some pictures here at the bottom, okay? Sun and Earth in June. So in June, the northern hemisphere, which is where New Jersey is, okay, is pointing towards the Sun, okay? The days are longer, okay, and the Sun is higher in the sky, giving it more concentrated rays. Now it's winter in the southern hemisphere because this hemisphere is pointed away from the rays. The days are shorter, okay, and that is their winter season. The reverse happens in December. In December, we are pointed away from the Sun, we have shorter days, and we have less concentrated sunlight. The southern hemisphere is pointed towards the Sun. Longer days, more concentrated sunlight. Okay, solstices and equinoxes. Okay, and if we look at the picture here, okay, we can see that an equinox is when we have spring, and an equinox is when we have fall. And think equinox has the word equal in it. Okay, we're going to be looking at seasons that have equal amounts of sunlight. Okay, the summer solstice and the winter solstice, those are our summer seasons and our winter seasons. Okay, now notice how we have opposites. Okay, so the northern hemisphere, okay, when we have winter in the northern hemisphere, it's summer in the southern hemisphere. When we have summer in the northern hemisphere, it is winter in the southern hemisphere. Okay, and it's the same for spring and fall. Okay, so the northern hemisphere and the southern hemisphere have opposite seasons. On June 21st or 22nd, the north pole of Earth's axis tilts towards the Sun. This event marks the summer solstice and the beginning of summer in the northern hemisphere. On this longest day of the year, the hemisphere receives more sunlight than on any other day of the year. 6 months later, on December 21st or 22nd, the North Pole points directly away from the Sun. This event marks the winter solstice and the beginning of winter in the northern hemisphere. On this shortest day, the hemisphere receives less sunlight than on any other day of the year. Twice a year, neither hemisphere is tilted toward the sun. Such events are called equinoxes. Periods of daylight and darkness are each 12 hours long every place on Earth. One of those events occurs on March 20th or 21st. This marks the vernal equinox, which is the first day of spring in the northern hemisphere. The second of these events occurs 6 months later on September 22nd or 23rd. This event marks the autumnal equinox, which is the first day of fall in the northern hemisphere. So when it is spring and when it is fall, we have 12 hours of sunlight and 12 hours of nighttime. Okay, and here is kind of an example of the graphs that we did yesterday in class. Okay, and let's go ahead now and read about the seasons. In everyday life, seasons are periods of a particular kind of weather. Earth scientists, however, define seasons by the position of Earth in its orbit. By this definition, all places on Earth have 4 seasons: spring, summer, fall, and winter. Yet, the effects of these seasons are extreme in some places, while they hardly exist in others. Near the equator, the sun's rays arrive at almost right angles. This causes the sun's energy to be more concentrated. Near the pole, the rays arrive at much sharper angles. This causes the same amount of sunlight to be spread out. This difference affects average temperatures. Look at the graph above. Places close to the pole, such as McMurdo in Antarctica, have cold weather all year long. Compare its temperatures to those of Panama City, which is near the equator. Other places have wide variations in temperatures throughout the year. Compare the temperatures of Chicago, Illinois, and Santiago, Chile. These cities are both about halfway between the equator and the pole, but are on opposite hemispheres. How do their yearly temperatures compare? A place's position on Earth is the most important factor affecting its temperature and seasonal changes. As you have read in other chapters, other factors affect climates as well. So what the chart is showing us is that Panama City, which is on the equator, basically has the same temperature all year long. McMurdo, which is in Antarctica, goes from cold to extremely cold, throughout the year. Chicago, we see, has cold in January, goes up to quite warm in July, August, comes back down to get cold again in December. The opposite is Santiago, Chile. When it is cold in January in Chicago, it is warm in Chile, because they have their summer. They're on the opposite hemisphere. They have the opposite season pattern. Ideas about the sun. Hundreds of years ago, people believed many false ideas about the Earth and the sun. As they looked up at the sky, they thought the Earth was the center of the universe. The sun and other objects appeared to revolve around it. In the 1600s, Italian astronomer Galileo published a book about the universe called Dialogue. The book presented evidence that the sun lay in the center while Earth and the other planets revolved around it. Galileo was arrested for promoting this idea. Today he is recognized for his courage and for being correct. Having built on the work of Galileo and others, scientists can now predict the positions of Earth, the sun, and other objects in space. Another false idea is that seasons come from Earth's changing distance from the sun. In fact, Earth's elliptical orbit brings it slightly closer to the sun in December than in June. However, the effects of the changing distance are very minor. As you have read, seasons are the result of Earth's tilted axis and revolution around the sun. The tilt causes the sun to rise higher in the sky and make the days last longer during the summer. The illustration shows how the sun appears to travel across the sky in the northern hemisphere. Its higher path in the summer provides more daylight and warmer temperatures. And this graphic here shows that when it's in the wintertime, the sun, in relation to the Earth, appears to just stay lower in the sky. And then in the summertime, it appears to be much higher. This causes longer days in the summer, shorter days in the winter. So you may go ahead now and using your copy of the packet, or you may go back and look at this video too, you may complete your handout.